Our first speaker, as I mentioned, is Dr. Marshall Shepard. He's from the University of Georgia. He is the Georgia Athletic Association Distinguished Professor there. He directs their Atmospheric Sciences program. We're really lucky to have him on the leadership team of the Georgia Climate Project. And I think as you come up, if the folks in the back are willing, we're going to roll a short video on what does climate change mean for Georgia, and then we're going to turn it over to you. So thanks again for being here, and I hope you enjoy the next day and a half.
One thing is clear. We're going to need to rely on the state's vast network of experts to best prepare Georgia for our climate future.
The Georgia Climate Project is an initiative that was founded in partnership between Emory University, Georgia Tech, and the University of Georgia, and rapidly expanded to include stakeholders throughout the state.
We have four main priorities: science, stronger conversations, solutions, and building a stronger network.
It's a nonpartisan, non-confrontational effort to think about the science and the solution space for Georgia in a way that all stakeholders can become involved in the process.
And at the end of the day, it's this stronger network that's going to be absolutely essential for Georgia to emerge as a real leader on climate change.
Thank you. And by the way, I want to mention good thanks to the folks that produced that video. I believe it was a group that is sort of a nonprofit. They contribute their time to producing videos on behalf of causes. And so I want to thank the organizers of that. I know Daniel knows exactly who they are, but that was an important contribution to this effort too. So if we can bring up my slides and we'll get started. I am Marshall Shepard from the University of Georgia. I suspect that I know many of you in the room. And so hello if I do know you, and nice to meet you if I just met you today. And so I want to talk about let's back off a little bit and get some of that feedback out of here. I want to talk today about the climate science motivation for this effort. The Georgia Climate Project, another effort called Georgia Drawdown. Those are important efforts, but there's a reason that we're doing them. And so I want to talk from the sort of, I guess I get the task of being the doom and gloom speaker. But as I said yesterday, it's not my personality to be doom and gloom. So I always try to find a way to circle back to the hope and optimism, even as we face the most significant challenge facing humanity, the climate crisis. So there are my coordinates, and I saw that particular graphic and I wanted to lead with that today. And the reason I wanted to lead with that is that the state of Georgia recently experienced Hurricane Michael. And Hurricane Michael is a hurricane, and if you talk to climate skeptics or deniers or contrarians or whatever they're called these days, they'll say, well, we've always had hurricanes and the climate has always changed naturally. And I was like, yes, duh, we've known that for some time. I'm a climate scientist. But we know that there is a human steroid on top of the naturally varying climate, and like grass, which grows naturally, if you fertilize soil, it grows differently. And so we see this warming ocean, we see a new generation of intense hurricanes, and we see a storm like Hurricane Michael that not only devastated Florida, but moved inland with 100-mile-per-hour gusts and harmed many of our valuable agricultural crops in southwest Georgia. So that's the sort of so what factor for me. So those are all the coordinates. Definitely follow, use the hashtag today. Please, let me, before I even go for it, please use the hashtag engage, because honestly in this room, we're preaching to the choir. But we've got to go forth and get the message, in our own sort of climate commission, if you will. And so what we want to do today is let people know what's going on here in Georgia. By now, most of you've seen this particular figure. It is a picture of the roadway connecting Tybee Island to Savannah. A hurricane didn't come through there. That's just a sort of king tide flooding. And I know people like Jill Gamble and others who spend a great deal of time on the coast, talk to people. And from what I understand from talking to Jill and folks that are working in the coast, people that live there say they haven't seen these types of things happening and with such frequency. And so this is a visual image of what we're talking about. There's another visual image. I actually like this one, the iconic climate stripes visual is getting around and making the rounds, but this just really draws your eye to the fact that over the last several decades, particularly the last 30 years or so, warming is ramping up. And as I said yesterday in a different meeting, if you can sort of stand thinking back to your your calculus days in high school, you learned about the derivatives, the rate of change. That's what worries us as scientists, how fast things are changing, the scale of the change on time. Not just that it's changing, but how rapidly it's changing. I mean, Daniel asked me to sort of set the context for how do we know it's us? Well, I mean, again, if you follow me on Twitter or if you've heard other talks, I actually don't like to talk about slides that show trend lines and maps and jargon, because I think to the average citizen or the average policymaker, they start to glaze over. But in this crowd, I'm going to show it. And so what we see here is an increase in temperature that's consistent with what I just talked about earlier. And as you may know, as you saw in the media, this past October was the warmest October on record, surpassing the October of 2015. And I mean, I get emails and calls from media like Seth Borenstein and Doyle Rice at USA Today all of the time asking me to comment for stories that they're writing whenever we see these types of things. And I'm like, guys, I'm going to stop sort of responding to this because this is no longer breaking news. I mean, if you're going to write stories about the warmest months and the warmest years, just sort of get you a template, put it in a Word file and save it and just repaste it, because that's going to happen. And so this is something that we have to convey. That's no longer breaking news, and that's alarming. So how do we know it's us? Because this is something, and I mean, by show of hands, how many of you deal with people that say, oh, yeah, it's the sun. Climate hasn't warmed since 1998. It's volcano. I mean, all kinds of things, right? I call them zombie theories because they live on like zombies, even though we've long refuted them from a scientific basis. They're called zombie theories. And so I've listed some of the zombie theories here in this graphic, but what this graphic clearly shows, and it's in the IPCC report and other reports, we can't reproduce in our climate models the level of warming that we're seeing unless we have anthropogenic change associated with greenhouse gas warming. When we just consider the natural forcings, now the natural forcings are important, so I'm going to go to this next slide. Here's one of these scientific sort of jargony type slides, but I'm going to break it down for you. I'm going to also make you hungry because I'm going to ask you to think about apple pie. Where is he going with that? I am a professor, so I have to give you a little pop quiz. What do you think in your mind is the most important ingredient in apple pie? The apples. Now, the reason I'm setting up this analogy in your mind, or this comparison point, is that I often have people telling me, well, it's the sun, or it's aerosols, or it's clouds, or volcanoes. No, for the climate change in our climate system, the apples in the climate apple pie is greenhouse gases. Let that marinate for a second. We can change the cinnamon and the sugar and everything in an apple pie, but the apples are the primary thing. When we look at this chart, we clearly see that in terms of what's driving the warming, the positive radiative forcing, greenhouse gases. Other things are certainly in the climate apple pie, aerosols, clouds, but it's the greenhouse gases. So I like to use that. I used to use in class an analogy of quiche, and I say, what's the most important ingredient in quiche? But my students look at me and crickets are chirping because I guess not too many of them eat quiche. So yes, climate changes naturally, and there are certainly things that we know that change naturally, and we get that, but it's actually anthropogenic contributions on top of this natural variability. I'll go back to that because I saw a few of you taking pictures of it. Actually, I don't know if I can get back to it. I don't think this actually is going to work, so I'm going to skip by it. Now, just to sort of wrap this up, just about a month ago, I testified before the House Science Committee in Congress. And one of the things that I told them in that testimony is that the extremes are becoming more extremes. And why that's important is that we as human beings, even animals in the ecosystem, We feel the extremes. We notice those more than slight changes in the averages. We feel hurricanes. We notice hurricanes, a flood, a heat wave, drought. Those are extremes. And one of the things that climate scientists have said for decades, and now it's a reality, is that the extremes would become more extreme. And that's what we're seeing. And why this is important for Georgia and why this Georgia Climate Conference is so important, and hopefully we can continue to lead as a state. By the way, Daniel didn't mention this, but in the National Climate Assessment Report that came out in 2018, the Georgia Climate Project, which is supported by Racy Anderson Foundation as well, was called out as an exemplar, as a best practice for how we move forward. That's at the national level. The congressionally mandated report calls out the Georgia Climate Project. And that's important because the South gets every type of extreme weather climate event you can think of. You can't think of another region in this nation that gets hurricanes, tornadoes, heat waves, drought, wildfires, cold, snowstorms, floods. We get them all. And so climate change and extremes, that's what we notice. That's what we're going to have to deal with. This is directly from a report that I was co-author on for the National Academy of Sciences, and it tries to make the case that extreme events are what will galvanize the public, policymakers, businesses, faith-based communities, the military, et cetera. And with that, I hope that, even though I sort of painted this picture and gave you a few nuggets for how to communicate this challenge ahead of us, what's heartening is that I'm standing in front of a room of over 400 people and 200 more that wanted to get in and couldn't. That should tell us something about the fact that whatever perception people have of where we live or the United States pulling out of the Paris Agreement, I'm optimistic because I see more action than ever. Thank you, guys.